Hey everybody, Adam Savage here. Today we are continuing our deep dive into the technology and testing of modern trucking tires. We last learned about the design innovations that allow Michelin's new X-Line Grip D drive tire to improve on the performance of their existing line haul tire. But I'm also fascinated about the manufacturing technologies and material science that make those designs tangible. So let's peel back some of that rubber and take a look at the surprisingly complex structures that make up a Michelin tire. Now, I know that you guys also have plotted out a retreading plan for these. Is there a different design for the tread for a retread than the original tire?
So you could imagine that there might be some different constraints, but really from a material and from a design perspective, you can use quite the same inputs.
Okay, because it's a known understanding of how you guys make the retreads the original tire.
In some cases, it's easier to make retread sculptures. Mm-hmm. We make them flat, so you pull them from a mold versus something round that you have to extract, right? And there's all kinds of creative ways in industry to figure out ways to do that, having less of an impact on, let's say, wear of parts or whatever you could imagine.
I don't think people realize out there in the world just how much structure there is built into a tire. Did the development of this new tire require any new structural elements within the casing?
Absolutely. So we have this is our new Duracore.
Okay.
And the key component is this 0-degree ply right here. In the old days, bias tires were just nylon plies stacked on top of each other in an X. And one of the big problems of bias tires is when you inflate them and heat them, they continue to grow. Right, nylon 6 was typical, and they grow and grow and grow and grow, which means the tire changes in how it wears,
right,
and it's very hysteretic. So you have lots of losses, lots of energy inefficiencies. So Michelin came up with the radial tire, and the radial tire has steel cords to keep everything from growing.
So it doesn't grow.
Exactly. In 1940s, we have the X design, so patented X, where there's two plies on top that form an X, which for narrow tires, keeps the tire from growing.
Okay.
Right? So a huge advantage in rolling resistance and a huge advantage in wear performance. With this new technology, the 0-degree ply and Finicoil, we're able to go a step further. It started with our X1 tire, which is two duals being replaced by one single tire.
Right.
And the problem is that the plies on X, you end up with this kind of gradient because they're so wide, you build tension.
Such a large surface area.
Exactly, and under torque, you have more wear where the rigidity's higher. So it's a trade-off. We have to find this balance. So Infinicoil is a way for us to simplify the stiffness across the summit. It's uniform. And so what it does for us in small tires is it allows us to further reduce the rolling resistance because we have this very flat, potentially very flat, if we want it to be flat, this very flat hoop
that creates a beautifully rigid
member. And we reduce stresses across the plies on X. So with that, so we can use it for wear and wide tires. We can also use it for rolling resistance for narrow tires.
It's repeatedly blowing my mind how much the physics of what you guys are dealing with is often at the tiniest scale on these giant things.
It is. So at 50 kilos, carrying 3,250 kilograms of load, they're very intricately designed. It's a very complex composite and very challenging.
How much of the design process are you able to use simulations, and how much do you have to go to real world? Where does one lead to the other?
Obviously, less and less. We've been developing simulation for 30 years.
And you're developing your own in-house simulation and understanding of...
We do, and we look outside as well.
Okay.
So we do a lot of in-house simulation as part of our design loop. I think Tyler talked to you about how many iterations we might go through. We do simulation on casing components. We do simulation on treads. We do simulation for specific performances.
I would imagine in the development of a brand new product like the new tire, the things you learn from that must change your analysis software for those simulations.
Absolutely. Absolutely.
Wow, okay, so it's like your own perfect feedback loop.
Yeah, and it's viscoelastic material. So when you think about characterization of materials, it's quite challenging.
That means rigid but flexible?
Exactly.
Okay.
And changes with temperature and age. So it's complicated. It's very complicated.
Wow.
So we have some samples here of tire cable.
Okay, and this is a practical example of this stuff we see here?
It is, and
Okay.
this is actually the radial cord, and it's called power coil. And the difference between it and previous generations is this cable is filled with rubber.
What?
So
There's a rubber core inside?
So there's many ways we can do it. It can be done during the process. It can be done prior.
Right.
So we fill the cable with rubber, and you think, why would you do that? The purpose of the radial cord is to carry the tension of the inflation pressure. Right?
Okay. And distribute it?
And distribute it. But
Okay.
inside of the tire is air, but also moisture.
Right.
And it turns out that all membranes aren't created the same. So this membrane is very good inside here to keep the air inside, to keep pressure. But there's actually a permeability of this membrane. You end up with oxygen and water moving through the membrane at all times because there's a huge partial pressure, this huge differential in pressure.
Right.
So we have maybe 9 bars hot on the inside or 9 atmospheres inside and 1 outside, right? So there's a constant flow of moisture, and having steel in a structure like that, you have to figure out how to protect the steel. One way to do that is to prevent the wearing of the cables.
Okay.
Right? So these cables, because they're twisted, as you cycle them in fatigue, they wear.
Right.
And
So work hardening over extended time.
And it's actually wear between the cables. So some friction
it's not
wear.
work hardening, it's actually friction. Oh, wow.
So you end up with oxides that then break down the cable, and it gets worse and worse. So one way to fix that is to fill the cable. So we designed this casing to go 1 million miles
Yeah.
in multiple retreads with lots of different circumstances. And part of a big component of that are technologies like this that allow us to break down paradigms and continue to move forward for the customer.
That is, my mind is blown. That's such a tiny change.
It's a tiny change.
That has a huge impact.
Huge impact. It breaks down everything. So these cords are very taxed in terms of fatigue, right? Because they're in the sidewall. They're also in the tread. Sometimes they get damaged from road hazards. They need to be repairable. There's other cords in the tire, like this Infinicoil, that has a very different life cycle.
Because of the wear patterns and how it's treated.
It's connected to the tread, so it ends up not having a lot of bending fatigue, but it has a lot of tension.
Right.
And so those two compromises are very different.
And you guys are always internally asking, could this part be better? Could that part be better?
Exactly. Wow. Exactly. Constant innovation. The steer tires we have here, they've been in the market for, something like this has been in the market for 25 years, and we're constantly tweaking. You asked about Regenion and the multiple ways we use it. Here's 3 different examples of how we use it. This is a long-haul steer tire. And
So this would be the
Regenion.
front tires of a truck.
Exactly.
Okay.
This is an example of a trailer tire where we expose the Regenion in some places, and in other places, it's not exposed. So there's a huge volume of water that can be evacuated in this tire, even though on the surface, it looks like there's not much there.
And doesn't need a ton of tread gription because it's a trailer tire.
Exactly. So it has very high lateral grip, which is what we need. And we can evacuate a lot of water.
Amazing. And
And this is a high wearing regional steer tire. So think that is a long haul, like trucks going back and forth from California and to the East Coast. And in this case, it's a regional steer tire, maybe on a grocery fleet, somebody hauling goods or whatever. So this is the X Multi Z2 regional steer tire. And here you have lots of biting edges, front tire, high grip, and also lots of Regenion. So we have a lot of water evacuation in these grooves and in this groove. So what looks to be something like a 3-rib steer tire now is actually 6.
Wow. So this is, I just love this. This is a tire for like highways, no turning.
Highway,
most
no
of the
turning.
Time. And this is, you're in a city, you're in an area, you're constantly moving around.
Lots of turning, high wear, high scrub. Yep.
Wow.
And this is our first generation where we have this Regenion technology in all of our molds. It's moving across categories where we can tune it in different ways, and there's a lot more to come.
It must be really exciting to be at the ground floor of a new innovation in the company and then watch that start to matriculate out through the product line.
It is very exciting.
Incredible. So, the X-Line Grip D tire is designed to perform better than its predecessor in winter climates, but we have to head to colder conditions to see how that performance is tested. My next stop, the frozen test tracks at Michigan Tech's Keweenaw Research Center. Hey, Jeremy.
Hey, Adam.
How are you, sir?
Good to meet you.
Nice to meet you. All right. This is the test platform, the test cab. So walk me through what is different about this cab. This is the testing cab, right?
Absolutely. This was a special order truck. It's a Western Star with a straight bed.
Yeah.
We use this truck for all sorts of different testing at our site in Lawrence Proving Grounds in South Carolina, but we bring it up here to Houghton, Michigan as well for snow testing. Today, what we're doing is acceleration on a snow surface with the big truck tires.
Okay.
So we've got some race logic data acquisition equipment. That's a V-Box.
And that's getting a signal from something that's monitoring a part of the truck.
Right. That's recording all of our sensors.
Oh, all of them at once?
Yes. Everything logs through there. So we can record on either the laptop or with a data card on there.
So what is the primary data channel we're recording here today?
So the main thing we're using to record data here is the wheel encoder on the back of the truck.
Oh, that's the thing bolted to the wheel that I saw outside.
Yeah, it's kind of cantilever
thing
off of the rear axle.
I love how simple that thing is.
It works.
It's totally amazing. And that's telling you, that's giving you all the information that you need, and we're recording that inside.
A lot of it, yes.
Okay. All right, Derek. We are in very cold northern Michigan right now, and we're standing in front of a truck, but it's also a test platform, isn't it?
Yep.
Okay, tell me what this test is built to discover.
So we try to use this truck to test out all the different scenarios that you're going to run into if you're driving in these snow-covered areas in the winter and just trying to do your job, trying to deliver the goods that people need, trying to get home at the end of the day, and to get the whole picture of the performance of these tires in the snow.
So it's trying to isolate the relationship between the tire and the road under all sorts of different road conditions, tire conditions, and I see you've even loaded up with a bunch of heavy steel weights.
Yep, so we load it up so that you have the standard load that you would expect to have on the axle of a truck. Obviously, you know, this is kind of a specialized setup, but we do our best to simulate the real world here.
Now, when you're setting up a test like this, am I right that a test like this probably has decades of predecessors of data that you guys have been gathering, that all the weights and the parameters are locked in, and you guys have been using them for decades?
Yep, we track all the weights, the conditions each day, the snow temperature, the air temperature. We look at everything to lock it all in, and then we can look back 20, 30 years even to see where the trends have been going and how our tire performance has evolved.
Wow. Okay, so what about the cold weather testing is unique for commercial vehicles?
For commercial vehicles, your cold weather testing really comes closer to like the traction limits of the tires. Whereas in other testing, you don't expect your customers to be near the traction limits all the time, especially in the dry or the wet.
Near the absolute edge of control.
In the winter conditions and cold and snow, your customers are much closer to it at all times. So it's really important to have a good understanding of where your products stand.
Okay, so we're going to do two tests with this truck, a subjective and an objective. And I know what those words mean in general, but could you describe them to me, and we could start with the objective test?
Yeah, so objective versus subjective is that objective is more on data capture, getting all the raw data and plugging that into a computer and churning out everything you can try to tease from the data.
Okay.
Subjective is more on the driver feel side. It's what you feel like when you're driving down the road. It's, you know, the butt dyno, when you say, oh yeah, I've made more power, I can feel it. Like that's the subjective side, is what you can feel.
Okay, and that means that you're also part of the test platform in addition to the truck.
Yep.
What does that mean when you're trying to isolate feel of the driving?
You're looking to feel how the tire behaves when you're getting close to the limit, when you're at the limit, and slightly beyond, just to feel, is it controllable? Is it natural? Do I feel like I have to fight the vehicle to control everything, or can I just let the vehicle settle itself out?
And if the vehicle gets out of control, how easy is it to recover from that loss of control?
Exactly.
And you're testing these under multiple road conditions, but also multiple tire conditions in terms of wear.
Yep, so we start with new tires usually, and then we also have worn tire testing just to simulate the end of life, because you only drive on new tires for about 1,000 miles. And at that point, you're on worn tires. So
most people, that makes total sense.
Most people are driving on worn tires. Yep. So it's important to have a good, safe product, even in a worn condition, because you don't want to buy new tires and then replace it halfway through because you're slipping and sliding all over the road. You've wasted half your money.
Yeah, I can imagine someone somewhere in history must have designed a tire that was excellent for the first 1,000 miles and then totally crapped the bed.
It happens.
Oh, that would suck. All right, so you are trying to design a nice ride for long-haul truckers, a difficult job. Tell me about your experience that you bring to this assessment job.
So, as a test driver, we spend at least the first year of our job just training to make sure that we get the same answers as the other test drivers that have been doing this for a really long time. And then specifically for heavy truck, we go and get our CDL, we make sure that we're on the road driving these trucks all the time, we listen to customer feedback. And like I'm gonna be driving a truck down south to South Carolina tomorrow on a 3-day trip because we need to get our tires back, but also it gets me in the real world, driving the trucks, feeling what our customers are feeling, and really getting a good chance to see what happens.
There's nothing quite like, I mean, test tracks like this are amazing, and there's also nothing quite like being in the real world.
You got to go use the tires like your customers are using them.
All right, sir. I love a methodology and I love a test platform. Let's get in the cab and go.
Sounds good.
All right.
This is so cool. We are about to do a set of what are called spin tests. And to zoom out a little bit, much of the testing of tires, from what I understand, is about examining the very small relationship between the tire and the road under all sorts of different conditions and circumstances, both for the tire and the road. Today we're testing that relationship under the snowy, icy pack conditions. And the spin test is basically they will drop the clutch, lurch the truck forward, and watch what happens by using this spinning indicator on it, which will tell them how many times the tire moves, et cetera, et cetera. And the test only lasts a few seconds, but don't let that fool you. Over the course of 25 tests for each set of conditions over the course of several days, they get a tremendous amount of data specifically about that relationship to keep these things on the road. It's so cool.
All right, Derek, I know that we're sitting out here in snow, but describe to me the road conditions we're testing on and what this actual test comprises.
All right, so the conditions we're on is a groomed snow surface that's been then packed down with a bunch of tires on a trailer to simulate a packed snow surface that you'd encounter on the road after, a couple days of heavy snow in the cold, white north.
Okay, and this is like a consistent finish you can put on the ground here.
Yep.
Amazing.
Yeah, we call up Toby Canary, the track manager, and he comes out and does his magic out here and gets it perfect for us every day.
So every time you're doing this test, you're doing it on the exact same kind of snow conditions.
Yep. And to maintain the same conditions across any different set, we also move sideways across the track, so that way we're not just going through paths that we've been through and torn up over and over again.
Right, that's why it's a nice wide pad. You've got a lot of room. So, okay, describe to me how that test is actually going to go when we perform it.
So I'll start, I've got a kickstand that holds the truck in place, and then I'll rev the truck up and drop the clutch, and then that's when all the magic happens with the data, capturing all the other things going on in the background.
So when you drop the clutch, there'll be a noise. It's going to be noisy when you do that, right?
It's a little violent when you drop the clutch.
Right, you're meshing two gears, and all of a sudden the back wheels want to turn.
Yep.
And you're measuring that metric.
There's a lot of stuff we're measuring.
Right, among many other things.
Among many other things, yep. Yeah.
And then we're going to lurch forward.
We'll lurch forward, and then the computer takes its data, and after a set amount of time, I'll stop, and then we do it again.
How many tests are you performing per tire, per set of tires? Where you're running them under all sorts of different conditions.
Yeah, so we run the tires, and we try to run all the tests at least 3 times to make sure that across different days that you get consistent results.
Right.
Because otherwise you'd have one day where, let's say the snow is a little extra grippy and a certain tire likes it better than other snow. If we got into all the properties of snow and the crystal structure.
But the goal is a background of consistency so you can really see what the results you're getting are.
So we can trust our results and they'll be applicable in real life scenarios.
Amazing. All right, so Derek, I think we're ready. Wait, your pogo stick's down? Yep.
Kickstand. Yep.
Kickstand, sorry. Your kickstand
hopefully it's not a pogo stick. I don't want to be bouncing all over this truck.
All right, getting the nomenclature wrong. Okay, kickstand is down. We're ready to do the test, yeah?
All right, yep. So the test, I start off in gear. Every tire I run the same way. So I start off in a gear and rev the engine up and then dump the clutch with the differential lock. Rev it up. You ready?
Yeah, talk me through the RPM. How are we?
So we revved up. The RPMs are kind of our own thing.
Okay.
But we can let you know later.
You're where you want to be.
Yep, I'm where I want to be, and then I'm just going to dump the clutch.
Okay. And that was a test. We just did one.
We did one of our spins.
One of 25.
One of 25.
When you're data gathering.
Yep.
Amazing.
It looks so violent down here.
It doesn't feel great, man. It doesn't feel great. But
Driving the truck in the opposite of the way you've been.
oh my gosh, I'm always worried I'm going to break something.
Really?
Yeah. But you want to give it a shot?
Really?
Yeah.
Oh,
Yeah.
that's allowed?
Hop on it? Yeah, go ahead.
Cool. Okay, cool. I want to just tell the camera right now, it's been 9 years since I've driven anything with more than 5 gears. So, here goes nothing. And I'm going to drop it in 3, 2, 1. And that's it. That's the whole test. Amazing. I love how efficient and bulleted this test is.
All right, that was pretty good.
That was so much fun.
Hey, by the end of the day, we'll get you certified to run this test yourself.
Amazing. Thank you for your careful instructions.
Oh, no
Very
problem.
clear.
You ready to go back, get the next set of tires on?
Yes. Absolutely.
All right,
Let's do it.
Let's do it.
Okay, so we've put a different set of tires on the
Yep.
truck. And the previous tires for the first test were the new tread.
Right, were the new tires, the X Line Grip D.
Okay.
And they were replacing the XDN2, and that's what we've got on now.
The XDN2s, and these are Michelin's bread and butter tires.
Bread and butter, made them forever. They've always been my favorite tire to put on any of our trucks that we're driving up into winter conditions.
All right, seatbelts on.
Seatbelts on, we're triggered. Rev it up.
Whoa!
I know, right? You can feel it right away.
I mean, you were saying to me before this test, you love these tires. You put these
These
on
are-
your trucks.
yeah.
You've driven thousands of miles on
Right,
these
we
tires.
put these on our trucks. This is what we drive to Michigan on. They're always what I choose.
It's astounding that that much improvement is possible.
Yeah. Wow. Like I said, I didn't believe it at first myself. You want to do it again?
I'll be honest with you, I didn't think this second test was going to be so clearly different than the first test, but now I'm going to get the driver's point of view of that, and I'm going to get to drive for some spin tests with the old tires. Brake is off. We're up to revs. All right, here we go. Dropping the clutch in. 3, 2, 1. Dude. There is just no comparison in terms of the gription of these tires between the new ones, which was the previous test, and the older ones, which is this test. It's clear to you that I've been hired to do these sets of videos for Michelin. But as an engineer, I want to point out that like all progress in engineering is often by the tiniest of increments. Look at the advantages in the efficiency of solar panels over the past 30 years. It is tiny percentage point by tiny percentage point. This is like massive, noticeable by a civilian. It's massive. It's really, really impressive. All right, Cyril, this is really cool. Tell me what this wall is.
This is a wall of materials that you can find in a tire. Okay, so we said 200 different materials goes in the composition of a tire. 200, okay? Wow. So this is examples of different materials that you can find in tires, from the cords that you can find, you know, in the carcass ply, for example, for an aircraft tire or a passenger car.
Passenger cars and aircraft tires don't have steel?
No. No. An aircraft tire has just one ply of steel that is ondulated on top to protect from what we call FOD, foreign object damage.
Okay.
Like things you will find on a runway. but mostly it's nylon after.
Okay.
Nylon and sometimes hybrid cords also, a mix of iron and aramid and nylon. Okay. Passenger cars are made of nylon or polyester cords, and the top is always steel. Okay, because this is giving the directionality and the carrying the load of the tire. Okay, so those example, you have also metallic cords, either to create what we call the bead, the things that goes on the wheel, to stick the tire on the wheel, or what you have in the summit. And then you have all the different interesting materials that you can find that are making the composition of the tire, like what we call SBR, for styrene butadiene rubber. So it's a synthetic rubber because tires are made apart with natural rubber, okay? Because it has certain properties that you cannot duplicate. Very difficult.
Even still, with all of our material science knowledge.
Yes, we cannot duplicate certain material resistance from the natural rubber. So we still use about, at the group level, about 24% of natural rubber group-wise, okay?
And in addition to that, everything here is found in
tires. So you have synthetic rubber, of course, to create the performance that you need. The performance, in rolling resistance, energy efficiency, wear, wet grip or snow grip. We use synthetic rubber. But you have also what we call fillers, like carbon black, explaining why the tires are black, in fact, because carbon black gives the resistance to the rubber. That was not existing before. That's why the tires were white or creamy at the beginning.
I always thought that they were black just to stop UV deterioration of the rubbers, but there's more to it.
No, it gives really resistance to the rubber. So that's why we use carbon black. Another important filler is the silica compound. While silica inside the tread has given the performance that you expect from modern tires today. This is something that Michelin invented with what we call energy tire line. The first tire line that were more efficient in fuel consumption and CO2 emission back in 1992. So it's not recent, and we introduced silica in the compound in that time.
Silica, otherwise known as sand, or
the
basis of glass.
Basically.
So there's glass in the tires.
Yes, pieces. And of course, you have also what we call agent for vulcanization that will create the link, the bond into the rubber. So that's why you have to cure the rubber to create and give its final performance. But also, resins, oils, and things like that will give the rigidity that we need, or the supple if needed. So for example, if you have a winter compound, winter tread, you want it to stay supple even when it's very cold. And we will use resins and oil to give that rigidity when it's very cold.
So these are all geared towards giving consistent performance from the manufacturing under multiple conditions.
Exactly. So that's why we need to understand under which condition you are going to use your tire. So we design the right tire for your usage.
All right, Derek, tell me the track we're on. What's going on here?
Okay, so we're on the stability test track.
Okay.
Similar to the other test areas that are set up for heavy trucks, this has been packed down as hard as it can be so we can run a 40,000-pound truck out here and not have to worry about tearing up the surface too much.
How thick is the snow ice on the surface?
We're standing on about a 10-inch base.
10-inch base,
so
10 inch base of hard-packed snow.
Yep.
I'm having trouble staying upright on just my own.
It's pretty slick right here. It's properly designed out here, groomed every day, just like the other test areas.
Oh, so they grade it all the time?
Yep.
To make sure it's the same conditions for your test?
They come out with groomers and packers and just make sure everything's nice and perfect for us each morning.
Okay, so the first test we did today was the objective test. That was using mechanical means to gather data from the tires. This is a subjective test.
Right.
So tell me what that means.
So subjective is all about the driver feel. What am I feeling when I'm behind the wheel? What is my own internal accelerometers telling me? And we do have a little bit of data collection just for some raw data to look at later, but I'm looking at controllability, peak grip, how the tire breaks free, how it recovers, and just how easy is it to drive in these pretty slippery conditions.
Yeah, and when we're talking slippery conditions, every driver is terrified of hydroplaning, and the mechanics of hydroplaning or skidding on ice are they're adjacent.
Yeah.
So this is literally a track for the worst possible road conditions that you're going to encounter in terms of a surface that's not friendly.
It's a hard packed surface that's very smooth. There's not a lot for the tires to grip on, so they're relying on the tire sculpture and the compounds that are in the tires to really give us the traction we need.
Okay, so tell me truthfully, it sounds like on a normal day when you're skidding a lot, it's probably a lot of fun.
I enjoy it.
I was sure of that.
I don't get many chances to show off a little bit,
Yeah.
so days like this are pretty fun for me.
When you're doing a run that comprises a test, how many circuits is it?
On each set of tires, we would do probably 3 or 4 circuits just to get enough data together and feel really solid about the results.
And in general, do you find a wide range in terms of, because I'm sure you're not just testing your own tires, you're also looking at competitors to get a regular
always.
picture.
Yep.
How often are you really surprised by the results from one of these tests?
Usually not very surprised at all
Yeah.
until we did this test right here. And I stopped in the middle of the test and was like, there's something wrong.
Really?
No tire is this good.
You
and
thought that some parameter was
I thought,
way off.
I thought we'd mess something up. Maybe we'd accidentally put on some brand new tires instead of worn tires. No, everything lined up.
So did you get out of the truck at that point and go through all the parameters for the test to make
I
sure
did.
they were all in line?
Yep, I called up my engineer back down at the track. He was home already. He's like, hey, we got to go through this step by step, make sure everything has been done properly on these tires to prepare them for testing.
All right, sir. So are we ready for the test?
Yep, we're ready. You want to
Excellent.
hop in and I'll take us around?
Oh, I can't wait. So just like the subjective test, you've worked hard with this test to eliminate variables
Yeah.
so that you can find and isolate and experience the thing you're testing for.
Yep, exactly. So normally what we're doing, steering sweeps and then go on throttle to get the rear tires to slide around. Then slow down again to get closer to my set speed. And do the same
Not
thing.
sliding very much.
Not really. This is what I was really surprised about this tire the first time I drove it.
Oh, I can feel that.
Just a hair.
Yeah, just a little bit. Awesome. It just immediately wants to grab back in.
Yep, it just lines itself right back up.
I can feel it like, nope. Amazing. This is making me feel like I didn't do enough truck traction myths on the show.
I know it's not why we're here, but this is fun.
Such a good feeling. Okay, this is the older tire set.
The older tire, the XDN2s, the tires that still, we've been using for a long time, loved them in the snow.
What kind of difference should we expect to see here?
So we should expect to see a little more oversteer, some progressivity, that it takes a little longer to recover, and just what is normal for a worn tire instead of what we saw on the X-Line Grip D.
So it's not a brand new tire, it's a worn tire.
Yep, so we've got both tires tested in a worn condition, because you don't drive on a new tire all the time.
Right, of course. So given that this is your bread and butter tire, am I correct in saying that your average trucker would expect and not be surprised by the performance here? This is how this is what tires do
This
in
is
terms
what
of the
tires
trucker's
do.
experience.
Yep, this is what they do. It's been it's been a product for a long time.
Yeah.
It's a known quantity, and it's expected.
Okay.
Now, of course, what I'm doing is something that no trucker ever wants to be in a situation of doing.
Exactly.
But it's my job to get the truck into these situations and see what happens.
And like we're to be clear, like this tire's already been engineered to get truckers out of this situation.
Right.
Dude,
right away.
right away. And this feels like very average hydroplaning to me.
Right, this is average, like what you expect out of a truck tire in the snow.
Yeah.
If you're going to be really provoking it and getting on throttle and
And you're on a
trying-
slippery surface.
Right, trying to do this,
Yeah.
it'll do it.
Wow. Dude. This feels so awesome.
Yeah. something I never want to actually do in a truck on the road.
No, every time I've recovered from hydroplaning, I was happy with myself, but I don't want that.
No.
All right, so now we're gonna do our slippy slides.
So now we see, looking a lot at the breakaway behavior to say, okay, so it breaks away really smoothly, and all I have to do is get off throttle, some steering, and it's corrected. This is what I expected to have on the X-Line Grip D.
So, like, this is average, so you must have been shocked when you rode those the first time.
That's why I was like, no tire's that good.
Dude, that is shocking. I mean, it's so predictably what skidding is that I'm weirdly more comfortable on this test.
You're more comfortable with this because like it's doing what you expect it to do.
Yeah.
Whereas on the other one, it's
just not losing traction.
Yeah. And that being said, like this tire is really nice. It's progressive on breakaway. It's easy to recover it. You're there, and then that's it. You're not waiting forever to bring it back around.
Right. It's a predictable amount of time, and it's like once you get used to it, you're there.
Yep.
Amazing. Oh yeah. Oh yeah. Oh, that's spectacular. So much fun. Oh. I want to thank Michelin, their tire designers, their engineers, and their test drivers for sharing their innovative engineering with us and for giving us a performance demonstration of their X-Line Grip D tires. You can learn more about X-Line Grip D by following the links below. I will see you next time.